On September 7th, 2025, the world watched as the moon disappeared behind Earth's shadow. But what truly stunned sky watchers came moments later. The sky erupted in neon green from horizon to horizon. Amateur astronomers captured a streaking icy blue comet that shifted impossibly to a glowing emerald, and the color lingered in the night even after the eclipse ended. Forums spiraled into chaos as professionals scrambled for answers. That was the night 3i/Atlas arrived, our third interstellar visitor, accelerating past Mars at 98 kilometers per second, carrying mysteries no telescope on Earth was ready for. Why would a comet from another star system paint our skies with a color science can't fully explain? Hours after the eclipse, the first images trickled in from backyard telescopes in Buenos Aires, Nairobi, and the outskirts of Lisbon. On the raw frames, a pale blue streak cut across the shadowed sky, its hue deepening to a saturated green that refused to fade even as the moon slid free of Earth's shadow. In Sao Paulo, a student with a borrowed DSLR caught the color shift in a burst of 10-second exposures. The timestamps, anchored to 3:18 Universal Time Coordinated, lined up with a sudden spike in amateur chatter. Never seen that shade of green holding after the eclipse. The color, the speed, it's screaming not local. In Cape Town, a retired engineer logged the object's angular movement through a 6-inch Newtonian telescope, noting a velocity so rapid that even a few minutes between shots showed clear displacement against the star field. The comet's apparent motion, nearly a quarter degree per hour, defied expectations for any known solar system visitor. Across Europe, observers compared notes on persistent emerald glow, arguing over filters and calibration, but the raw data told the same story. The green lingered, refusing to wash out under city lights or fade with the moon's return. In the hours that followed, forum threads ballooned with uploads, stacked images, spectral traces, hand-drawn sketches. Metadata poured in coordinates, exposure times, filter bands. A teacher in rural Turkey posted a time-lapse that captured the color transition frame by frame, while a high school astronomy club in Morocco measured the comet's position shift against background stars, confirming its breakneck pace. By dawn, the evidence was global and unmistakable. The object's color and speed were unlike any comet in living memory. Amateur networks, usually slow to agree, converged on a single conclusion. This was no ordinary visitor. The world professionals, still silent, were about to receive a data flood they couldn't ignore. By 7 o'clock Universal Time Coordinated, the phrase, "night the sky went green," had already become a hashtag. The world's telescopes, from backyard rigs to 10-meter giants, were now pointed at a single fast-moving green visitor. The handoff from public curiosity to scientific urgency was complete. The clock was ticking, and every minute counted. Inside the Atlas control room on July 1st, 2025, the first data drop from Cerro Tololo triggered a familiar script. Run the detection to the orbit solver, check for known asteroids, flag anything out of place. But the software stalled. Each attempt to fit a closed elliptical orbit spat out residuals that refused to settle. The numbers pointed to a path that didn't loop back, didn't belong to the sun. Eccentricity above 1, hyperbolic. Not just a statistical fluke, but a mathematical wall. A small team of analysts gathered around the screen, watching as the residuals climbed with every tweak. Standard protocols call for waiting. Collect more data, rule out a spurious detection, avoid clogging the confirmation pipeline with false alarms. But the object's apparent speed and trajectory kept breaking the model. A log entry at 3:14 Universal Time Coordinated captured the unease. If this is real, it's interstellar. If not, we waste the world's time. One analyst, recalling the panic of Oumuamua's discovery, pushed for escalation. The minor planet center was pinged, flagged with an urgent note. Fit unclosed, eccentricity greater than 1. Possible ISO candidate. The debate in the control room turned from caution to calculation. How many hours until follow-up would be impossible? Every minute lost meant a shrinking window. By 5 o'clock Universal Time Coordinated, the team moved as a unit, prepping the alert for global distribution. The interstellar flag was raised. For the third time in history, the software could not bind the orbit to the sun. The Minor Planet Center alert went out at 5:12 Universal Time Coordinated on July 1st, 2025, stamped with the object's preliminary designation and a warning: orbit fitting failed. Eccentricity above 1, outbound velocity unbound. Within hours, the object acquired a formal name: 3I/Atlas, the third confirmed interstellar object after Oumuamua and Borisov. The datasheets told the story in numbers. At discovery, 3I/Atlas was already moving at 61 kilometers per second, and trajectory models projected a perihelion speed close to 98 kilometers per second. That's fast enough to cross the distance from Earth to Moon in just over an hour, far beyond the reach of any probe, rocket, or planned interceptor. Orbit dynamics specialists, some of whom had spent years modeling hypothetical extrasolar visitors, watched the residuals climb in real time. The hyperbolic path was clear. This was a one-time pass, a cosmic drive-by that would never repeat. The official circulars flowed. C/2025N1 Atlas, reclassified as 3I/Atlas, flag as interstellar, and added to the short, exclusive list of solar system trespassers. The impossibility of interception settled in quickly. No existing mission, not even the fastest solar sail concepts, could hope to match velocity or trajectory. With the closest approach to Mars set for October 3rd, 2025, at nearly 29 million kilometers, the window for in-depth study was vanishingly narrow. The notification process, once a formality, now triggered a global scramble for remote observations. Every telescope, every spectrograph, every available eye was needed before 3I/Atlas slipped away for good. Spectrographs from La Palma and Gemini South began streaming data, and before sunrise, their raw outputs combed by gas phase analysts searching for the familiar fingerprint of C2, the molecule behind the classic green glow in nearly every comet on record. But the data told a different story. Instead of the sharp swan bands near 516 and 563 nanometers, the green region was dominated by a broad, featureless plateau. Line by line, the expected dicarbon signature was absent. Infrared scans layered on another surprise. Carbon dioxide, not water, towered above the rest. CO2 outnumbered H2O by a factor of 8, a ratio seen in no comet from the inner solar system. The usual water-driven chemistry was flipped on its head. Cyanogen, a molecule that sometimes boosts blue-green hues, appeared in modest quantities. Carbonyl sulfide barely registered. Neither could account for the intensity or persistence of the green emission. In the control rooms, specialists swapped hypotheses in real time. Some pointed to dust scattering, but polarimetry argued against a simple explanation. Others ran through lists of rare radicals and exotic volatile compounds, but none matched the observed color. The absence of C2 left a chemistry-shaped hole at the heart of the anomaly. For now, the only certainty was that 3I/Atlas had rewritten the color rulebook. The green glow was real, unmistakable, and by every standard measure, unexplained. Spectrographs in the world's largest telescopes began to light up an unexpected signature. More than 20 distinct nickel lines, several in the ultraviolet, all standing out with a sharpness that left little doubt. Iron, usually the partner in any comet's metal emission, barely registered. A handful of weak lines, some right at the detection threshold, most missing entirely. The ratio was so lopsided that in some frames, nickel outshone iron by a factor of 50 or more. For comet chemists, this was a chemical fingerprint from another world. Laboratory teams, some still running overnight cryochamber experiments, scrambled to match the spectra. Nickel carbonyls, volatile at temperatures colder than any solar system comet, became the leading suspect. In the lab, these compounds can sublimate at minus 25 degrees Celsius. But in the deep interstellar dark, they might linger for billions of years, waiting for a stray sun to pass close enough to trigger release. Iron, by contrast, tends to lock into silicates or heavy grains, tough, refractory, and stubbornly invisible to the spectrograph. Polarimetry added another twist. The dust grains in 3I/Atlas scatter light with a deep negative polarization, a pattern seen mostly in the outer solar system, in trans-Neptunian objects, not inner comets. That combined with early Hubble imaging, pointed to a compact nucleus, likely no more than a few kilometers across, wrapped in a CO2-rich coma. The physics of this dust, tightly packed, submicron, and unusually cohesive, suggested a birthplace far beyond the frost line of any ordinary star. For planetary scientists, the stakes sharpened. The chemistry on display wasn't just exotic. It was a direct clue to the way planets and comets form in the coldest reaches of the galaxy. The clock was ticking for lab replication. With Hubble and JWST soon to be blinded by the sun, all eyes turned to Mars orbiters for a last shot at capturing the metal vapor and dust physics before 3I/Atlas vanished into deep space. Mars became the fallback. With Hubble and the James Webb Space Telescope locked out by solar elongation, the only way to catch 3I/Atlas during its critical pass was from orbit around another planet. The Mars Reconnaissance Orbiter and MAVEN, both deep into their own science campaigns, faced a sudden high-stakes retasking order. On September 10, 2025, a classified memo from NASA's Planetary Science Division landed in the mission manager's inboxes. Prepare for a target of opportunity campaign, effective immediately. The object would sweep within 29 million kilometers of Mars on October 3rd, a distance close enough for high-resolution ultraviolet and infrared instruments to dissect its coma and tail, but only if the window was seized. The politics were fierce. Mars climatology teams fought to keep their seasonal data uninterrupted, citing years of baseline measurements at risk. Engineers scrambled to rewrite targeting software, repoint sensors, and negotiate observation slots with international partners. Congressional science committees weighed in, demanding the unique interstellar event take priority. In the end, the science division broke protocol, pushing through full approval in just 48 hours, a process that usually drags on for weeks. By September's end, the Mars outpost was on alert. Instrument teams rehearsed rapid-fire observation sequences, knowing the comet speed, nearly 98 kilometers per second at perihelion, left little margin for error. On October 3rd, as 3I/Atlas made its closest pass, both orbiters captured spectra, ultraviolet flashes, and atmospheric readings impossible from Earth. In 3 hours, MAVEN returned more data on metal vapor and coma structure than most missions gather in a season. The gamble paid off. Mars, for a brief window, became humanity's only eyes on an interstellar visitor. In late 2025, software engineers at TESS and the Rubin Observatory confronted a hard truth. 3I/Atlas had slipped past their algorithms not once, but twice. Archival frames from October 2023 and June 2024 showed faint, fast-moving traces, barely above the noise, but real. Detection pipelines, tuned to filter out hyperbolic or color-odd candidates to avoid false alarms, had quietly discarded the very signals that mattered most. The post-mortem was swift and unsparing. Machine learning developers, some still sifting through old logs, began rewriting code to flag outlier trajectories and green-leaning color bursts in real time. The new mandate: no more missed interstellar visitors, even if it meant more false positives and midnight phone calls. Mission architects, watching the data review unfold, pushed for a more radical fix. If software can't guarantee early warning, then hardware must be ready to launch at a moment's notice. Proposals for rapid response interceptors, solar sailcraft, modular instrument swarms, even disposable CubeSats moved from white bars to funding decks. The technical specs were bold: launch within weeks, ride solar pressure to match hyperbolic speeds, and swarm any inbound object with sensors before it vanishes. NASA, ESA, and private teams weighed rival blueprints, each promising the agility that 3I/Atlas had exposed as missing. For the next visitor, the plan is clear. Survey triggers fire on odd colors and unbound orbits. Interceptor fleets stand ready, not just to watch from afar, but to meet the next interstellar messenger halfway. The lesson of 3I/Atlas is written into every line of code and every mission concept. Cosmic surprises demand readiness, not regret. In October 2025, 3I/Atlas passed within 29 million kilometers of Mars, its closest approach captured by Mars orbiters after Earth telescopes went offline. Confirmed as only the third interstellar object ever detected, its 98-kilometer, per second perihelion speed and hyperbolic path were verified in Atlas and Minor Planet Center records. Spectra revealed intense neon green light, yet the classic C2 swan bands were absent. Instead, carbon dioxide dominated over water by 8-1, and more than 20 strong nickel lines appeared without matching iron, breaking all known comet patterns. Despite global observations and urgent data collection, the true chemical source of the green glow remains unresolved. Archival tests and Rubin data showed early traces missed by older software, prompting survey upgrades and mission proposals for rapid interception. 3I/Atlas is left, but its anomalies force a new standard. Every interstellar visitor brings unique evidence about planetary origins, and readiness depends on what we learn from each one. The sky may have returned to normal, but the questions linger. What star system did 3I/Atlas call home? What ancient chemistry shaped its nickel-rich heart? And most haunting of all, what will the next visitor bring? 3 weeks after 3I/Atlas disappeared beyond the orbit of Jupiter, a graduate student at MIT made a discovery that would send shockwaves to the scientific community. Maria Chun had been running computational chemistry models, trying to recreate the green glow in simulation. At 2:47 a.m. on October 24th, her algorithm converged on something impossible, a molecular structure that shouldn't exist under natural conditions. A nickel-based polymer chain, stabilized by carbon monoxide in ways that required temperatures below -200 degrees Celsius and pressures found only in the depths of interstellar space. She stared at her screen, hands trembling. The structure wasn't just exotic. It was a smoking gun. This molecule could only form in one place, the molecular clouds between stars, where matter condenses over millions of years in the absolute cold of space. But there was more. When she ran the emission spectrum, the model produced an exact match to the green glow that had painted Earth's sky. She had found it within hours. Her advisor was on the phone with NASA. Within days, laboratory teams at Caltech and the Max Planck Institute were attempting to synthesize the compound. The first successful creation came on November 2nd, 2025, in a cryogenic chamber in Pasadena. Under ultraviolet light, the synthetic sample glowed the exact shade of emerald green that had mesmerized the world. The implications were staggering. 3I/Atlas hadn't just been a comet. It was a chemistry lab from another star system, carrying molecular blueprints that Earth-based science had never imagined. The news broke on November 5th. With headlines that captured the public imagination, Interstellar Visitor carried alien chemistry, and the green glow explained, and it's more remarkable than we thought. But Maria Chun wasn't finished. Late one night, reviewing the archival spectra from Maven, she noticed something the automated systems had flagged as instrumental noise, a series of narrow absorption lines in the ultraviolet, rhythmic and repeating. She enhanced the signal, filtered out the interference, and what emerged made her blood run cold. The pattern was too regular to be natural. Spaced at precise 1.7 nanometer intervals, the absorption lines created a mathematical sequence. 2, 3, 5, 7, 11, 13, the prime numbers. She ran every possible natural explanation through her models. Molecular resonances, magnetic field interactions, quantum effects in the dust grains. Nothing fit. The pattern persisted, clear and unmistakable. By dawn, she had called an emergency meeting with her advisor and 2 senior astronomers. They sat in stunned silence as she walked them through the data. "Either this is the most extraordinary coincidence in astronomical history," she said, voice steady despite her racing heart, "or 3I/Atlas was carrying something deliberately structured, something meant to be found." The debate that followed was fierce and immediate. Within the scientific community, battle lines formed. Skeptics argued for exotic plasma physics, unknown quantum effects, anything but the conclusion that seemed to be staring them in the face. Believers pointed to the mathematical precision, the impossibility of natural processes creating such a pattern. SETI researchers, who had spent decades listening for radio signals, were both vindicated and frustrated. The message had been hiding in plain sight, in the light itself. The discovery triggered an international crisis of urgency. If 3I/Atlas had carried a deliberate signal, and if there were more interstellar visitors en route, humanity needed to be ready. The president convened an emergency science panel on November 15th. NASA's budget for interstellar object detection and interception was tripled overnight. The European Space Agency fast-tracked its Interceptor mission, a fleet of 12 standby spacecraft designed to launch within 72 hours of detecting any hyperbolic intruder. But the real race was happening in deep space. Astronomers began reanalyzing every piece of archival data, looking for traces of previous visitors that might have been missed. And they found them, faint trails in decades-old photographs, dismissed as artifacts or distant asteroids. Objects that had passed through the solar system in 1979, 1998, and 2014, all exhibiting subtle anomalies that now demanded re-examination. On December 3rd, 2025, the Rubin Observatory detected something new. Designation: 4I/Prometheus. Distance: beyond Neptune's orbit. Velocity: 87 kilometers per second. And in its spectrum, hidden among the sodium and calcium lines, another pattern. Not prime numbers this time, something more complex. A sequence that looked suspiciously like the fundamental constant of physics. The ratio of the proton mass to the electron mass, the fine structure constant, the speed of light. The world held its breath. Interceptor 1 launched on December 8th, riding a heavy-lift rocket into a trajectory that would intercept 4I/Prometheus in April 2026. For the first time in human history, we would meet an interstellar visitor up close, with instruments specifically designed to look for signs of artificial structure or deliberate messaging. As December turned to January, every major observatory on Earth and in space maintained a constant vigil. The sky became humanity's inbox, and we were finally reading our mail. The discovery of 3I/Atlas's molecular signature and the potential signal had transformed our understanding of our place in the cosmos. We were not alone in leaving messages for others to find. In laboratories worldwide, researchers worked around the clock to decode the patterns, to understand what the chemistry was trying to tell us. Some believed the messages were simple proof of concept. We exist and we know you're out there. Others thought they might be more. Maps, warnings, or invitations to a conversation that spans light years and millennia. Maria Chun, now thrust into the spotlight as a decoder of the first potential interstellar message, continued her work in relative quiet. She had been offered positions at every major institution, but she stayed at MIT, in the same lab where she'd made her discovery. Late at night, when the building was empty, she would pull up the spectrum of 3I/Atlas on her screen and stare at it, wondering who had sent it, how long had it traveled, and most thrilling and terrifying of all, were they still out there waiting for a response? On January 15th, 2026, an international consortium announced the Beacon Project, a network of powerful lasers designed to shine pulses of light encoded with mathematical and chemical information into the directions for which the interstellar visitors had come. If someone was sending messengers, humanity would send a reply. The first transmission was scheduled for March 2026, aimed at a region of the Cygnus constellation where trajectory analysis suggested 3I/Atlas had originated. The message was simple: the same prime number sequence that had been found in the comet spectrum, followed by our own chemical composition, our location in the galaxy, and a new sequence, one that represented the structure of DNA. We were writing back. As 4I/Prometheus drew closer in Interceptor, one race to meet it, the world watched with a mixture of hope and fear. The night the sky turned green had opened a door we could never close. Beyond that door lay questions that would define the next chapter of human civilization. Who shares this galaxy with us? What do they want us to know? And when we finally meet them, in person or through the messages they've scattered among the stars, what will we say? The comet had come and gone, but its legacy blazed brighter than any star. We had learned the most important lesson of all. We're not just observers of the cosmos, not just students learning from distant messengers. We're participants in a conversation that began before our species evolved and will continue long after we're gone. And somewhere out in the dark, traveling faster than any ship we could build, 3I/Atlas carries its green glow into the depths of space, a messenger that delivered its gift and moved on, leaving us forever changed. The night the sky turned green wasn't an ending. It was an invitation. And humanity, for the first time in its history, had finally learned to read the stars. Interceptor 1 reached 4I/Prometheus on April 3rd, 2026, at 14:22 Universal Time Coordinated. The spacecraft high-resolution cameras activated at a distance of 50,000 kilometers, and what they captured would redefine everything humanity thought it knew about the universe. The comet wasn't a comet at all. Mission control at JPL fell silent as the first images streamed down. Dr. Sarah Okonkwo, the mission director, leaned forward in her chair, her coffee forgotten and cooling. On the main screen, 4I/Prometheus revealed itself, a perfect dodecahedron, 3 kilometers across, its surface etched with patterns that caught and reflected sunlight in rhythmic pulses. "That's not natural," whispered the imaging specialist beside her. "That's architecture." The spectroscopy team worked frantically, comparing their readings to the patterns Maria Chun had found in 3I/Atlas. The match was undeniable, but 4I/Prometheus's signal was stronger, clearer, more insistent. As Interceptor 1 swept past at a relative velocity of 12 kilometers per second, its particle detectors registered something impossible: organized magnetic fields, pulsing in sync with the prime number sequence. Then came the moment that changed everything. At closest approach, 4I/Prometheus activated. A beam of coherent light, not reflected sunlight, but generated from within, locked onto Interceptor 1. For exactly 47 seconds, the spacecraft's instruments were flooded with data, terabytes of information, compressed and encoded in layers upon layers of mathematical structure. Then, as suddenly as it began, the transmission stopped. 4I/Prometheus continued on its trajectory, accelerating slightly as it rounded the sun, leaving humanity with a gift it would take decades to fully decode. By May 2026, teams of cryptographers, linguists, mathematicians, and physicists had made the first breakthrough. The outermost layer of the transmission was a Rosetta Stone, a dictionary that mapped their mathematical concepts to ours. Once that layer was peeled away, the next level emerged: star charts. Not just any star charts. A map of the galaxy showing the locations of 847 stellar systems, each marked with a symbol. Maria Chun, now heading the international decoding effort, recognized the pattern immediately. The symbols weren't random. They were chemical signatures. Each star system was tagged with a unique molecular fingerprint of the object that had visited from there. They're not visitors. Maria announced at the emergency UN Security Council meeting on May 18th. They're probes, a network of them, scattered throughout the galaxy. Someone built a communication system using comets as messengers, and we've been walking through their library without knowing how to read. The room erupted. Delegates shouted questions, demanded proof, called for verification. But the data was irrefutable. Deep within the transmission were images, actual photographs, of the civilization that had built the network. Not humanoid, not anything like the science fiction movies had prepared people for. Crystalline structures, vast and intricate, living in the clouds of gas giants. Beings made of organized electromagnetic fields, for whom solid matter was as alien as they were to us. They called themselves the Weavers, and they had been sending their messages for 3 million years. But there was more, hidden in the deepest layer of the transmission. Protected by encryption that took the world's most powerful quantum computers 6 weeks to crack, was a message that sent ice to the hearts of everyone who read it. A warning. The star map showed not just the 847 systems of the Weaver network, but something else. Dark regions, spreading like a stain across certain spiral arms of the galaxy. Systems that had once been part of the network, now silent. The pattern was clear and terrifying. Something was systematically destroying the relay stations, moving slowly but inexorably through the galaxy, dismantling the Weaver's great work. The transmission included observations, data, desperate attempts by the Weavers to understand what they were facing. An expanding sphere of silence. Civilizations going dark. Probe networks collapsing. Whatever it wasn't natural. It was deliberate, methodical, and it was headed toward our region of space. The Weaver's estimate. It would reach our neighborhood in approximately 50,000 years. The message ended with coordinates, a system 200 light-years away, where the Weavers had established their most important archive, a vault of knowledge, protected and hidden, containing everything they had learned in their 3 million years of watching the galaxy. And then, in the final lines of decoded text, something that read like a prayer or a plea: "We spread our knowledge because knowledge is the only weapon against the dark. Understand what we have learned. Add your own wisdom to the great weaving. Warn those who come after, as we have warned you. The silence approaches, but the conversation must continue. You are not the first to read these stars. You will not be the last. Make yourselves ready." On June 1st, 2026, the President addressed a joint session of Congress and a watching world. The speech was broadcast in every language, to every nation, translated in real time. "We stand at a threshold," she began, her voice steady despite the magnitude of what she was about to say. "For the first time in human history, we know with certainty that we are not alone. We know that intelligence has evolved elsewhere, has flourished, has built wonders across the galaxy. We also know that existence is not safe, that even civilizations millions of years old can face threats they cannot overcome alone. The Weavers have given us a gift, warning and time. 50,000 years may seem like an eternity, but measured against the lifespan of civilizations, it is merely a moment to prepare. The question before us is not whether we will face this challenge. We will, or our descendants will. The question is whether we will face it as a divided species, or as a united one. The resolution that followed, passed with unprecedented speed, established the Office of Deep Time Security. Its mandate: to ensure human civilization survival and to add humanity's knowledge to the Weaver network. Plans were drafted for self-replicating probe swarms, for generation ships, for archives that could survive millions of years. Humanity began to think not in terms of years or decades, but in terms of geological epochs. On July 15th, 2026, the Beacon Project sent its first deliberate response into the cosmos. Not just a simple acknowledgement, but a full participant's introduction to the Great Weaving. Humanity's history, our science, our art, our mathematics, all compressed into a format that matched the Weaver protocol. The transmission included our own molecular fingerprint, the nickel polymer compound that Maria Chun had synthesized, but modified with a uniquely human addition. Complex organic chains based on carbon and nitrogen, stamped with the signature of DNA. More importantly, the message included humanity's observations of the spreading silence. Earth's astronomers had begun their own survey, checking the Weaver star maps against current observations. Several of the marked systems showed anomalies, unusual dimming, unexpected spectral changes. The dark sphere was real. It was even closer than the Weavers had estimated, perhaps only 40,000 years away. We added our data to theirs. Our warning to their warning. Our small contribution to the great conversation. By August 2026, the sky had become humanity's most important frontier. Every amateur astronomer, every telescope, every space agency maintained constant watch for new interstellar visitors. The detection protocols Maria Chun had helped develop were now running on thousands of systems worldwide, all coordinated through a central hub at the newly established Institute for Interstellar Studies in Geneva. On August 19th, they found 5 I/Chrysalis. On September 3rd, 6 I/Meridian. On October 12th, 7 I/Beacon. Each one carried more data, more pieces of the puzzle. Some were ancient, launched millions of years ago by the Weavers. Others were newer, sent by civilizations that had received the Weavers' message and added their own knowledge to the network. Humanity discovered it had joined a conversation involving at least 23 different species, spanning millions of years. Each new probe brought warnings that refined the picture. The silence wasn't just one thing. It was a cascade of effects, a breakdown in the fundamental structure of interstellar space itself. Some species called it the dimming, others the unweaving. A few, in translations that barely made sense to human minds, described it as a universe forgetting how to dream. No one knew what caused it. No one knew how to stop it. But every civilization that had encountered it agreed. Cooperation was the only path forward. Unity across light years and millennia was the only response to a threat that operated on such scales. 1 year after 3I/Atlas had painted Earth's sky green, Mariachin stood on the roof of the MIT Observatory, watching the autumn stars emerge. Below her, in laboratories and offices around the world, thousands of researchers continued the work of decoding, understanding, preparing. Her phone buzzed with an alert. Another interstellar visitor detected, this one designated 8I/Testament. She pulled up the preliminary data, her practiced eye immediately catching the chemical signature in the spectral readout. This one was different. The molecular structure included elements she'd never seen before, arranged in patterns that suggested technologies far beyond human capability. The probe wouldn't reach Earth's vicinity for another 3 months. Plenty of time to prepare, to point every instrument at it, to extract every bit of knowledge it carried, and then, perhaps, to add something to it before it continued its journey, a human addendum to whatever message it bore. She looked up at the stars, at the great river, the Milky Way stretching across the dark. Somewhere out there, 3I/Atlas was still traveling, still carrying its green glow into the depths of space. Somewhere, the weavers maintained their patient vigil, tending their network of knowledge across the light years. Somewhere, other species were reading the same warnings, making the same preparations, adding their voices to the great conversation. And somewhere, perhaps 40,000 years away, but approaching with the inevitability of time itself, the silence spread. But not tonight. Tonight, the stars still spoke. The messages still flowed. The conversation continued. Mariachin smiled and went back to work. Humanity had 40,000 years to get ready, and she had a translation to finish before dawn. The night the sky turned green hadn't been an ending or even just an invitation. It had been humanity's first day of school in a university billions of years old. And the real lessons were just beginning. 50 years later, the archive vault buried beneath the Antarctic ice contained humanity's contribution to the Weaver Network. Everything we'd learned, everything we'd become, all compressed into formats designed to survive for millions of years. But more importantly, it contained the probes, thousands of them, ready for launch. Each one a perfect dodecahedron, 3 kilometers across when fully deployed, its surface etched with the patterns that would mark it as part of the network. Each one carrying not just humanity's knowledge, but humanity's hope. In 2076, the first human-built interstellar messenger launched toward a system 50 light-years away. By 2100, there were hundreds fanning out across the galaxy. By 2200, thousands. Humanity had joined the conversation not just as listeners, but as speakers, not just as students, but as teachers. And in the data streams flowed between the stars. If you knew how to read them, you could still see traces of that first night. The impossible green glow, the mystery that started it all, the moment when humanity looked up and finally understood that the stars were not just things to wonder at, but voices to answer. The silence was coming, but the conversation would be ready. And somewhere in the depths of space, 3I/Atlas continued its eternal journey, the messenger that had changed everything, carry its green glow like a torch passed across the light years, from hand to hand, from mind to mind, from civilization to civilization. The night the sky turned green was the night humanity learned to read. And everything that followed was our reply.